Hello, everyone. Dear authors and invited guests, it is my great pleasure to welcome you to the 6th International Congress on Information and Communication Technology through Zoom on behalf of ICICT 2021 and Global Knowledge Research Foundation. As every one of us is passing through the unseen circumstances due to COVID-19, we wish everyone and their families a safe time. Further, with immense happiness, I would like to share with you that we have received an overwhelming response this year from across 90 countries, where 1,150 papers were received and 350 papers were accepted, contributing to the success of this conference. And the papers will publish in 4 volumes this year. We are thankful to all our guests present on this platform to join us digitally for the conference in these unpredictable times and make this conference more fruitful in terms of technical knowledge, and hope you will enjoy the 2 days of knowledgeful and interactive sessions. I would like to welcome you to the technical session 5E and further introduce you to the chair of this session, Dr. Alexander Rykov. Dr. Alexander Rykov is a professor, Doctor of Technical Sciences at State Advisor of the Russian Federation of the Third Class, winner of the Russian Government Award in the field of Science and Technology, professor of the Miria Russian Technological University, leading researcher of the Institute of Controlled Science of Russian Academy of Sciences, head of Artificial Intelligence Department of the National Center of Digital Economy of the Lomonosov Moscow State University, director of the Center for Artificial Intelligence of the International Research Institute of Management Problems, scientific leader of the Expert and Analytical Center of the Institute of Tax Management and Real Estate Economics of the Higher School of Economics. Welcome everyone, and we will start our presentations by Dr. Joaquim Neto, who will present multi-agent-based recommender systems, a literature review. The floor is yours.
Are we beginning? Yes, or in 10 minutes?
Since yes, we can start.
We can start now. Yeah.
Okay.
Yeah.
Okay. I have a problem with the sound. I think you are.
We can hear
okay.
you well.
I will start my presentation.
Yes.
Okay, let's go. And
okay. Good morning to everyone, and thank you all for attending this presentation, where I will present my work related to a multi-agent based recommender systems, a literature review. My name is Joaquim Neto, as I've told, and I am a PhD student at the Universidade Aberta in Portugal. The outline of my presentation, I will start with the motivation for this work. I will talk about briefly multi-agent systems and recommender systems, the concepts and definitions, the research methodology of this research work, the literature reviews, research results, publication research results, and finally, the discussion and conclusion of the paper. Our motivation comes from two main reasons. The first is that the areas of recommender systems and multi-agent systems plays an essential role in my research interests. And second, in my ongoing PhD thesis, I'm studying and developing a multi-agent system for recommending fire evacuation routes in buildings based on context and Internet of Things. So it becomes fundamental to perceive the state of the art of the research domain that brings together these two technologies, multi-agent and the recommender systems. Concerning some definitions, there is no consensus concerning the concept of an agent, and in the literature, and so different authors define agent according to the use that each one makes of the term, being possible to find multiple definitions. We present here the Aldridge definition that states that an agent is a computer system that is situated in some environment and is capable of autonomous actions in this environment in order to meet its design objectives. Concerning Jennings also states 5 characteristics, important characteristics of the autonomous intelligent agents. Are entities capable of solving problems, receive as input the state of the environment where they are located through sensors acting in the same environment through actuators. The agents are designed to serve a specific purpose and have specific goals to achieve. Agents must exhibit flexibility and have control over their behavior in order to pursue their goals, and they have to be proactive and reactive. So a multi-agent system is a system composed of several autonomous intelligent agents capable of working cooperatively or competitively to achieve objects difficult to achieve by an individual agent or by a monolithic system. Concerning recommender systems, Reishi, Rockoa, and Shapira defines a recommender system as a set of software tools and techniques that provide items, recommendations for users to use. A recommendation can be seen as a reference to an item, for example, a web page that is made available to the user that are looking for the information searched. A typical recommender system aggregates and directs the recommendations to the appropriate recipients, as told by Way, Moreau, and Jennings. So recommender systems can provide quality recommendation to users because such recommendations are based on their past preferences or the preferences of other users with similar interests. And the recommender systems have the main purpose of supporting and stimulating users in their decision making, providing them with the items that best suit their interests. Concerning recommender system classifications, they are classified according to the way recommendations are generated. That typically, traditionally, the well-known approaches are content-based approaches, where items with content similar to those that user has shown preference in the past are recommended. Collaborative approaches, the recommended items are those that users with preference similar to those of the active user have liked in the past, and hybrid approaches that combine techniques and of both content-based and collaborative approaches to fulfill the main objective. Adamovich et al. Referred that collaborative and content-based approaches only consider the item user pair, so context-based approach also considers contextual information. For example, in our solution of PhD thesis, the context is very important, and you can get them with, for example, with sensors or with IoT devices, because and the contexts are related with the fire, with the smoke, with the toxic gases, with the congestion of routes inside the building. Other approaches that are also considered are knowledge-based, demographic-based, and utility-based approaches. Concerning our research methodology, our goal is to build a comprehensive bibliography of research papers on the area of multi-agent-based recommendations. We searched several databases, started with Google Scholar, as well as Science Direct, ACM, IEEE, and Springer Link. And you followed three main steps in our research, our search methodology. You first start for looking for existing literature reviews on recommender systems, and in second step you search for publications specifically dedicated to recommender systems and multi-agent systems, and based on the search results we identified and selected a set of papers that you think represent the state of the art in the area of multi-agent based recommender systems according to purpose and domain application, types of approaches, and the main contributions of each one. Concerning the first step of our work, we found many literature reviews and surveys, many dedicated to recommender systems in general. I highlight here four works because of their meaning and impact. They are very large, cited in literature. We also found many literature reviews targeting specific domains, such as e-tourism and e-learning, or literature or surveys related to particular approaches, such as content-based, collaborative, hybrid approaches, and context-based.
We still have 2 minutes.
Okay, thank you. So we found an enormous quantity of literature reviews on recommender systems, but none of those literature reviews are specifically focused on multi-agent based recommender systems. In more than 500 articles analyzed by those literature reviews that I mentioned in the last slide, less than 20 of them rely on recommendation solutions based on technology of multi-agent systems. So we think that is the demonstration of the interest of this work. Concerning publication search results, we found more than 150 publications that meet the search criteria. After a thorough analysis, we select a set of 15 papers that we consider representative of the state of the art on multi-agent based recommender systems. And our analysis of the research papers focus on the following dimensions: application domain, main contributions, type of recommender approach, and theoretical versus practical papers. Concerning discussion and conclusion, the application domains are diverse, general purpose for e-commerce, e-tourism, e-learning, financial market, energy management, social networks, Internet of Things. In all of these kind of domains, we found the combination of recommender systems with multi-agent systems. Concerning recommender approach, most of the works follow collaborative approaches. Very significant the presence of hybrid approaches, which is not surprising given the typical characteristics of multi-agent systems. Most of the reviewed works are practical or refers to practical applications, and most of them being developed with the JADE framework. Concerning main contributions, all papers contribute to strengthening knowledge in the area of recommender systems and multi-agent systems, and we highlight some improvements that result from the use of multi-agent systems technology, namely new ways of combining implicit information and explicit information, system modality, possibility of splitting the system into several parts, and ability to run in lightweight devices such as smartphones, accepts new recommender agents in runtime, running different algorithms for generating the recommendations, a new way of combining collaborative and content-based algorithms, and the ability to improve the collection of contextual data acquired on Internet of Things. As a conclusion, the incorporation of recommender systems in websites and web applications helps users to obtain the information or service they need and when they need, or to alleviate them from information overload. Considering this distributed nature of the Internet of Things, and their propensity to assist in solving complex problems, the multi-agent systems appear as a good support for recommender systems. And in our survey, we identify and describe several multi-agent based approach applied to recommender systems in the most diverse areas of application. And so thank you. I'm available for any questions. Thank you.
Thank you. Thank you for the presentation. Any questions?
I'd like to ask you one question, if you don't mind. I think that the history of multi-agent system, it's something about 50 years. What do you think about it? That's one question. The second, you did not tell us something about artificial intelligence, neural networks, different instruments from artificial intelligence for this system. What can you tell me about age of this history and this problem, and about using the method of artificial intelligence, for example, neural network system? Thank you.
Thank you. As I understand, if I understand your questions concerning the age of this technology, they are old. About 95, I think the evolution is is developing more, but it's still in the field, and are very important in artificial intelligence, because they are able to, the multi-agent systems are able to combine different kinds of artificial intelligent algorithms. Okay, because of its characteristics. In our work, you are thinking to use multi-agent systems to help guide the occupants of a building during a fire incident. Okay. However, of course, neural networks and other ones may be used, and in my literature review related to the fire evacuation, it's possible to found this kind of other solutions related to artificial intelligence to help users to help occupants of the building found the best route until they are safe.
Thank you. 95 years of the history. Thank you very much. Very interesting.
Thank you all. Now we move on to Dr. Ziad Tilalek will present two-phase approach for solving the rich vehicle routing problem based on Firefly algorithm clustering. The floor is yours. Yes, if you can unmute yourself.
Okay, hi. You can see my screen.
Yes, we can.
Okay, great. So as you said, my name is Sead, and I'm working at the Faculty of Science at University of Sarajevo, and a software company called InfoStudio, based in also Sarajevo. Today, I will present you a paper about two-phase approach for solving rich vehicle routing problem based on Firefly algorithm clustering. To begin with, this paper actually addresses the problem of vehicle routing problem, which is one of the hardest and most complex optimization problems in the field of combinatorial optimization. Basically, we have a starting point for all vehicles, which is called depot. We have available fleet of vehicles, and we have some customers to be served. The main goal, of course, is to serve all customers, to get feasible routes, and to deliver everything that has to be delivered. Of course, to begin with, we have to calculate distances between each two customers and between customers and depot, which is basically in our practical approach done by using some services like Google or Grabhopper, etc. Of course, to speak about vehicle routing problem, we have to add some realistic constraints, such as time windows. Of course, each customer can say that we can deliver goods at some time interval. Of course, vehicles have their capacity, which actually makes the problem harder because we have a heterogeneous fleet of vehicles. So each vehicle has its own capacity, and it just cannot be violated at any moment of the routing process. Of course, we have some other constraints such as working hours, balanced routes. We have some customer vehicle restrictions and so on. When we consider all those problems, we are speaking about rich vehicle routing problem, which is even harder version of the standard vehicle routing problem. In literature, we have a few standard approaches actually to this problem. First of all, we have classical algorithms such as genetic algorithm, taboo search, etc., which actually have some nice results, but in practical applications, there can be some problems. Of course, we have other approaches based on modern nature-inspired optimization algorithms such as beta algorithm, Firefly, Fireworks, elephant heading optimization, and so on. In this paper, I will present you a two-phase approach, which is actually based on, of course, as I said, two phases. First phase is clustering process, which is actually done by the usage of Firefly algorithm. In the next phase, we are routing and solving a vehicle routing problem for each individual cluster. But why is this problem? Why is this possible? Because we are making one hard optimization problems with large dimensions. We are reducing it to few smaller problems with smaller dimensions. So we can solve those problems with the usage of standard and simpler approaches. So basically, just to illustrate everything, we have customers, many of them. We have the location of the depot, which is starting point for each vehicle. And then in the first step in the first phase, we are clustering everything. What's important is to mark that cluster where the depot belongs. So if we have those clusters, we will use customers from the depots cluster to supplement other routes just to get better and most and better solutions. So when we route everything, when we solve vehicle routing problem for each clusters, those customers are those routes are supplemented by customers from the depots cluster. In the first step, we used Firefly algorithm, which is actually nature-inspired meta-heuristic based on fireflies and their behavior in nature. This is a standard optimization algorithm, which is actually implemented by Xin-She Yang, professor. And we have few key points here. First of all, we have to determine the number of clusters at the beginning, which can be approximated by a number of customers and vehicles. We have to define the objective function. We have to generate the initial population, and we have to define movement operator between fireflies. Our approach is to divide everything into clusters where we can solve each clusters by using 2 plus minus 1 vehicles per cluster. So that is approximated by the equation given here. The objective function here can be modified, which is actually the greatest advantage when we compare this approach with some other standard clustering algorithms such as k-means and so on. Of course, the initial population is chosen by those customers that we already have. So we are not choosing some random points in the space. We are choosing points that are actually customers, so as centroids. Distance and movement operators are slightly modified when we compare them with original version, because we for each centroid we are finding the nearest centroid in other Firefly, and we are doing the movement just between those two centroids. When we create customers and their clusters, we are actually routing each cluster individually. So first of all, we have to define their priorities, which can be done on many ways. And basically, this is one of the things that we can modify to just for practical use. We have to define the objective functions, the goal function, and we have to solve vehicle routing problem for each of these clusters. As I said earlier, this problem is much easier when we have smaller number of customers, because we can use some simple but efficient algorithms such as to opt and so on. And at the end, we are supplementing routes with those customers from the depot clusters, which can create better solution. This vehicle routing problem is solved by priority based on number of constraints. So if we have more constraints, that we are routing that cluster before, because we want to have as many available vehicles at that point. Objective function is calculated as a total cost, so it's basically a linear combination of loading cost, cost per kilometer, and so on for each vehicle, which actually represents the real cost in reality for this routing. And in this approach, we are solving smaller vehicle routing problems by two opt algorithms. Because this is an efficient way which actually produces some great results for smaller instances. So we have a few dozens of customers which can be easily done by 2 or 3 opt algorithm, and it actually produces some nice results. So because we have to solve that problem for many combinations of vehicles, we have to have some efficient way to do that. And at the end, we are adding customers to our routes. We are finding the best customer for that depot cluster, and to add it to beginning or end of the route, which is actually not costly, computationally costly. Results, we compare this approach with some other standard approaches for clustering. So as with manual clustering, which is actually done by company management. This approach was implemented in some large distribution companies in Bosnia and Herzegovina in their warehouses. We had few algorithms to compare. First of all, taboo search was implemented before, so we compared everything with taboo search, which is actually a standard approach for addressing vehicle routing problem. We compared everything with manual clustering vehicle routing problems with clustering obtained by k-means algorithms, and of course this algorithm based on Firefly. So we tested everything on 30 days of warehouse operations. Taboo search has some taboo search actually had some disadvantages because sometimes it gave unfeasible routes. So when we have unfeasible routes, of course, it's not possible to route everything, and actually the customer is not satisfied. So this approach actually obtained some nice results because we got all feasible solutions. It's much faster than the taboo search because we have smaller problems and the clustering is actually really fast, and we actually got some lower costs for all routes that we compared. So today this approach is of course implemented in those warehouses. Short conclusion. Okay, great. So we got feasible routes. We got everything much faster than we had solutions before, and actually we got lower costs, and routes which are easily modified in some cases because our customers are much more satisfied by them than before. This area has a great possibility of practical applications because it can be implemented not only for distribution companies. And of course, in the meantime, between this paper and writing and this conference, we implemented some other algorithms such as BET algorithm, elephant herding, fireworks, and so on. So in some cases, we got even better results. So we think that there is a great possibility to improve this process by doing everything. And at the end, I would like to thank the company InfoStudio for giving us actually all necessary data and possibility to work on these problems. And I am ready if you have some questions.
Thank you. Thank you for your presentation. Any questions?
I think that we have to make some questions for every speaker. For example, it's thank you very much. Very interesting idea, clustering. Can you tell me, did you try some exotic algorithm? I noticed that you told about genetic algorithm. For example, what we use, ant algorithm. Did you use it? It's not classical. But
yeah, of course.
Your opinion, please, about ant.
Yeah, of course. My PhD research is actually based on those meta-heuristic approach, so I implemented many of them. So in my opinion, ant colony optimization works great for some problems, but in these cases, I actually looked for some other papers based on ant colony and so on. But this Firefly approach is great for clustering, as the literature said. So basically, that algorithm produced much better results than those other approaches. But I saw some researches where the vehicle routing problem is not done in 2 phases, but it's addressed by ant colony optimization. And of course, as a traveling salesman and so on. So we did not implement it in this case, but in some earlier problems, because we were working on some researches in warehouses where we have routing bit for workers and pickers and so on. We used actually ant colony there, and it got us some nice results.
Oh, thank you very much. Good idea with clustering. There are something about 50 methods of clustering we try to
of course.
solve. Okay, thank you.
Thank you all. Now we move on to Dr. Rashmi Maldini, who will present a machine learning approach to CCPI-based inflation prediction. The floor is yours. You can share your screen and unmute yourself.
Hello, can everyone hear me?
Yeah, we can hear you.
Okay, thank you. I'm Rashmi Maldini, and I'm here to present to you my research paper on a machine learning approach to CCPI-based inflation prediction. This was done as part of my postgraduate MSc degree, along with my supervisor, Mr. Alroy Maskrengi. First of all, let me introduce you to what inflation is. Inflation is actually the economical phenomenon where the cost of goods increase and the buying power of the general public decreases, affecting the living cost of the public. So it has to be closely monitored and taken into consideration when national policies are derived. In Sri Lanka, the Central Bank of Sri Lanka is mandated to create policies, and in every other country, there is a regulatory body that is assigned to do this procedure. The problem here is that at present, mostly linear models are used for predicting inflation. But however, with the advancement of data science, now there are certain machine learning concepts that have eliminated any nonlinear modeling challenges and therefore have advanced the inflation modeling arena. However, these concepts have rarely been explored in Sri Lanka, and therefore this research proposes a machine learning predictive model to the Sri Lankan context, which is capable of predicting complexities to inflation with a higher rate of accuracy and also flexibility. First of all, we did a literature review where we found that most models are of 3 types. First, statistical, second, artificial intelligence or machine learning based models, and next, hybrid models. However, the statistical models are the dominant type of models in the research arena, whereas there are a few artificial intelligence and machine learning models. Hybrid models are only like a handful. However, out of the artificial intelligence and machine learning models, artificial neural networks and random forests are the most used ones. And out of statistical models, time series models and ARIMA-SARIMA models are the most widely used ones so far. First of all, moving on to the methodology, first of all, we did information and data gathering where we interviewed modelers and we observed the existing process and got suggestions from the people who are actually doing it. And we identified all possible criteria that could affect inflation based on certain economical concepts. And finally, the data was obtained using publicly available sources of the Central Bank of Sri Lanka. Next was the selection of inflation determinants. This was a very important step in the project because each country has certain variables that affect its economy specifically, as in the determinants chosen for Sri Lanka may not work for another country because the economic environment is different. So the selection of inflation determinants was done freshly and carefully, specifically for the Sri Lankan environment, considering the time period and also many other key economic phenomena that was happening in the country. Moving on to the data overview, the period was from 2014 to 2019. The source of data were from public data libraries of the Central Bank of Sri Lanka. There were eight determinant variables that were identified from the selection process that I mentioned before. And the selected determinant variables are broad money supply, narrow money supply, credit to the private sector, monthly average exchange rates, average rate deposit rate, average rate lending rate, average rate fixed deposit rate, and the rice price. Some of these variables are very new to the Sri Lankan economic, Sri Lankan inflation prediction arena, because mostly only like 2 or 3 variables are used. But however, we explored many variables and tried to find if there are more variables that are connected to this prediction process. The outcome variable was the Colombo Consumer Price Index. Moving on to data preprocessing, we use regression as the imputation method and box plots for identification of remedial identification and remedial measures for outliers. Multicollinearity was detected using VIF values and metric plots. And then the data was split to 80% training and 20% testing, followed by data normalization and scaling depending on the model. So we tried 6 models on the data set. The 6 being artificial neural networks, random forest, KNN, support vector regression, which is the regression correspondent of support vector machine, extreme gradient boosting, and linear regression. And we used 4 validation measures, which are root mean square error, mean absolute error, and mean absolute percentage error. Moving on to the first model, which is the AND model. For this, we did the data normalization, and the functions used for the computation hidden layers and the hidden neurons were decided on a trial and error basis. So iterative models were built starting from an initial model using 1 hidden layer and the RPROC algorithm, which is an improved version of the usual backpropagation algorithm. The architecture of the tuned model is shown here. So we got that the optimum model, the one that gave the lowest errors, had 2 hidden layers with the activation function RPROC. Next, the random forest, which is a supervised machine learning technique, which builds models from multiple decision trees, was used. In this algorithm, the tuning corresponds to finding the optimum number of trees and the number of splits. So as you can see from these graphs, the minimum error is obtained when the number of trees is approximately 450 and the number of splits is approximately 6. So therefore, these 2 parameters were included and the optimum model was obtained. We also found from the random forest model that there are 3 main variables which are of high importance for the model, which were broad money, credit to the private sector, and exchange rate. Moving on to the k-nearest neighbor method, which is comparatively a simpler supervised learning technique. In this, the cases are regressed or classified based on a similarity measure, such as the Euclidean distance. And normalization was also done using an EZ score to avoid effects of extreme values. Here, the trick is to find the best K value. And as you can see from this graph, the best K or the lowest error measures correspond to a K value of 2. So therefore, this was used for the optimal model. Moving on to support vector regression, which is a non-parametric regression technique that depends on kernel functions, which are functions that are used to identify relations between data and for pattern analysis. For nonlinear relationships, it was found in literature that most efficient kernel function would be the radial basis kernel function. So this function was used. as well as a cost parameter was used to improve predictions through error optimization. As you can see, from the performance results of the SVR model, we actually tried out 1,100 different models to come out with these results by using an epsilon from 0 to 1 and the cost parameter from 1 to 100, which gave 1,100 models. From all these models, we found that the best epsilon and cost combination would be when the epsilon was 0 and the cost was 17. And the best performance was 2.32, which is the MSE. The tuned SVR model is shown here, and it had 27 support vectors using the radial basis kernel function. Moving on to extreme gradient boosting. XGBoost is an implementation of gradient boosted decision trees, which improves speed and performance. There are actually three main concepts used here: ensemble learning, boosting, which is the optimization of weak models, and gradient boosting is the concept that is used for boosting in this model building methodology. And the boosting happens in such a way that it uses the previous model's pseudo-residuals. So in each iteration step, the new model is built in such a way that the previous model's errors are improved. For extreme gradient boosting, we used three boosters, mainly GB-tree, DART, and GB-linear. However, the best errors were reported for the DART booster, and therefore the most optimal model was obtained through the DART booster. Next is the linear regression model. This is actually a model which has a statistical background, and therefore certain statistical assumptions had to be satisfied. Although linear regression is a statistical model, in machine learning, the approach focuses on error optimization as opposed to describing the relationship between predictors and responses in statistics.
2 minutes left.
Thank you. So linear regression is done using gradient descent concept to find out which features should be used to get the minimum error. So this is actually part of linear regression, feature engineering, which is done using stepwise and backward elimination processes. These are the requirements that need to be fulfilled when linear regression is applied, and that those were done using Anderson-Darling and other relevant statistical tests. As you can see, the best linear regression model was obtained when there were only 3 features. Moving on to the accuracy comparison of all models, irrelevant of the MAE, MAP, RMSE, and MSE validation criteria, it was found that support vector regression, random forest, and KNN were the best models for the problem at hand. And therefore, SVR, or support vector regression, was chosen as the best model to predict inflation among all models. The high impact variables were broad money supply, exchange rate, and credit to private sector when random forest was used. And in linear regression, it was broad money, exchange rate, and narrow money. There were a few limitations, which were that this prediction was only relevant to headline inflation, and only CCPI based inflation was predicted. And also monthly data was used, but if weekly or daily data were available, it would have been more efficient. As future enhancements, I would like to suggest machine learning hybrid models where you can use the SVR, the best model, with another machine learning model such as RF and combine the two and see if it improves the results. Also ML-stat hybrid models, because machine learning is known to be a black box, whereas statistics can be more transparent about the results. So you could use machine learning and stat hybrid models in future. And you could expand this model to predict other price indices, such as the national price index. and also exploration of more determinants and more ML algorithms, including deep learning techniques, would be beneficial. And the exploration of training to testing ratio is also a promising area. In conclusion, I would like to say that this study actually focused on improving Sri Lanka's CCPI-based inflation prediction through a comparative machine learning approach, and 6 supervised machine learning models were used, where the best accuracies were obtained for support vector regression, random forest, and KNN, respectively. Although ANDs and RFs were very popular models in literature, it should be noted that the amount of data used for the study has an impact on which algorithm works on which data. So since the amount of data is limited, we found out that SVR is the algorithm that works better on a limited quantity of data, and therefore it beats artificial neural networks and random forests in the same arena. Therefore, this research concludes that SVR is the best individual machine learning model to predict the CCPI-based inflation of Sri Lanka in terms of accuracy and flexibility. Thank you very much.
Thank you for your presentation. Any questions from?
There is question in the chat.
Yes.
There are two or one questions.
Mm-hmm.
In chat. There is a question in chat. No.
Yes, there are 2 questions, I guess. If the chair of the session would like to read them up. I will read them. So there is a question. Why not consider feature selection to select factors instead of expert input? Expert input limits our ability to build data-driven machine learning models and introduce bias.
So expert variables were used, but also certain variables that we thought were good by reading literature and by past experience was also used. So it was a combination of both expert and feature selected bias used in the study. And what was the data frequency is one of the other questions. We used around 1,500 data, so which is actually a limited number of data in comparison to most machine learning techniques. But it is through this limited sample of data that we found out that SVR algorithm works better than an RF for this kind of data. We wanted to consider linear regression because linear regression is one of the main techniques used at Sri Lanka at present. So that is why, and because linear regression is a statistical technique and it has the feature engineering concept attached to it in a statistical sense. So that is why we wanted to see why how linear regression would compare with the SVR. And since it is linear regression and it is not a non-linear method, it did give us low accuracy results. So yeah, we wanted to see if that really was the case. So, and since it is used here, that is why we included it.
Okay, any more questions? So
I hope I answered all the questions.
If they want to ask you questions, they can send you through the chat forum or to you directly.
Okay.
Because we are limited in time for the questions.
Okay.
Now we will move on to Joseph Marvin Imperial, presenting cross-textual analysis of COVID-19 tweets on themes and trends over time. The floor is yours. You can share and
Okay, can you hear me?
Yes, we can.
Okay, thank you. Okay, hello everyone. My name is Joseph Marvin Imperial from National University Philippines, and I will be sharing my research entitled Cross-Textual Analysis of COVID-19 Tweets on Themes and Trends Over Time. Okay, so before I go with my discussion, here is an overview of the flow. I will first introduce the background of the research, what my research goal is, the methodology of how I can achieve the research goal, the results and evaluation, discussion about the results, and to be ended with the conclusion. So first, an introduction. We all know that what COVID-19 did to almost all countries all over the world. So with the recent pandemic caused by COVID-19 virus, countries all over the world immediately shifted to quarantine mode in hopes of alleviating the spread of the virus. So what happened is that most countries had to shut down schools as well as other establishments. They had to transform face-to-face classes to online classes. Traveling was banned. Lockdown was placed everywhere. So in the Philippines, the entire country was placed in an enhanced community quarantine, or sometimes called ECQ, starting from March 16 to May 31, 2020. So that's roughly around 3 months. Now, I would like to open the topic about the use of social media during these times. Social media plays a really big role, an important role in terms of information dissemination, especially during times of natural crisis such as pandemic. So it can take a form as a participatory media where or the people or the public can share content, can share information, can share sentiments, opinions, and so on, and be an active member in terms of distributing information. Now, since Twitter is widely used, wherein there are 330 million active users all over the world. And in the Philippines, we have around 10 million active users every day. It can be considered as a valuable tool to hear what the people are talking about, what sentiments are being shared, what information are being shared over the platform on how they perceive the day-to-day life during the pandemic. So my research goal is simple. In this study, we just want to take a look at the prominent topic or themes and its trend of usage over time as means of further intervention initiatives for the government, and in terms of understanding how the public react in times of pandemic. So we want to hear the pulse of the masses, or what the public is saying. So in order to do that, we collected over 50,788 public tweets in Filipino using the search term hashtag COVID within the Philippine boundary and within the specific duration of 1 month allowance within the enhanced community quarantine placed in the Philippines. So that's February up to June. So table 1 shows the breakdown of tweets, the number of tweets collected each month. Now, before we model our data, we perform basic pre-processing steps such as lowercasing, removal of stop words, symbols, numbers, characters, and numeric characters and white spaces, as well as duplicates and retweets, so that we can work on a clean data set. Now, in order to understand or to extract uh, important or prominent topics, there is what we call topic modeling in natural language processing. Now, this is a method of automatic topic discovery of underlying topics in a large body of text. So as you can see in the visualization, the intuition behind topic modeling is that you are going to try to model or try to sample the correct number of supporting topic words and number of topics for the entire document in such a way that it's easy to interpret what the entire corpus is about, or what the entire corpus is talking about. Now, the algorithm that we used for topic modeling is the latent Dirichlet allocation formulated by Blay in order to extract the topics from our tweet dataset. Now, just glossing over the algorithm or the generative process of LDA, it works by sampling the possible number of topics in the tweet corpus, and you are going to sample the uh, possible number of supporting topic words per topic. So the entire tweet corpus can be composed of a number of topics, and each topic can be composed of a number of topic words. But the challenge is that when you are selecting your topics and topic words, it has to make sense. Now, in order to do that, we have to evaluate the performance of the topic models with the help of perplexity scores. Now, the perplexity score is just a metric for probability-based models in which it will test if a certain test sample observes the same structure or is possibly generated from the uh, partition data set or the trained set. Okay, so we have to control two hyperparameters, which are the number of topics and the learning rate of the model, in such a way that we have to find the optimal values for these hyperparameters in order for the topic model to generate sensible topics. Now we perform hyperparameter optimization with the help of grid search or exhaustive grid search over a series of values for number of topics and learning rate. So we explored number of topics of 5, 10, 15, and 20. And for the learning rate, we just obtained default values from existing work such as 0 0.5, 0 0.7, and 0 0.9. Now performing the grid search algorithm, we arrive at the best scoring topic model composed of 5 topics and a learning rate of 0 0.9. So from that, we can infer that with the corpus used in the study, prominent topics discussed by the public within the collection time frame can be limited to 5 central themes or 5 main themes. Now, here is the 5 themes that we were able to extract from the entire corpus. So you have tweets about longing, in which the supporting topic words are Lord, and soon, wait, free, city, house, and think. You also have tweets about awareness. Filipino people were trying to spread awareness information over Twitter. So you have their need, wash, government, community, China. You also have their tweets about hope, tweets about work from home experience, and tweets about testing concerns, because there is a certain period of time that we Filipinos were very much concerned with the COVID testing in our country. Now, we found something interesting by cross-referencing the themes that we found with existing related work using topic modeling in the Philippines. So we compared our works with the work of Ancheta et al., in which they performed topic modeling, but they used tweets published during a typhoon, and also on the work of Maceda et al., wherein they used tweet data published before, during, and after earthquakes. Now, we compared these 3 data sets and the findings of these papers, and we discovered that positive emotions such as love and hope stand alone as a topic in the form of sentiments shared online through social media platforms like Twitter, are universal across the mindset of Filipino. So whatever natural calamity or crisis, if you perform topic modeling within that specific time frame of that crisis, you are bound to expect that there is a separate topic or prominent topic that is about love or hope. Now, aside from getting the prominent topics, we want to look at how these topics changed over time as we progress along the enhanced community quarantine. So there is a uniform increasing trend in all themes and topics where the significant usage is within the month of March. So for example, here the topics longing and awareness, they spike during the month of March, as well as for the topics of hope, work from home, and testing concern. Now, as we progress along time, there is a decline in usage of these themes on Twitter, which signifies that as the country progresses forward, the public is slowly adjusting towards the environment and thus lessen tweet activity. Okay, so that's the same observation can be seen for the entire topics. And lastly, there are some notable spikes in some of the themes, even though we have progressed forward. So for example, in the testing concerns topic, the supporting topic word free spiked mid-April, signifying increased discussion and demand on free COVID testing for the masses or for the Filipino masses. So the same can be inferred with work in the work from home topic, emphasizing the need for jobs as a primary source of income.
2 minutes left.
So, okay, just to conclude, in this study, we perform thematic, two types of analysis. First one is thematic, in which we extracted 5 central themes from the tweet data set within the search parameter. And we found out 5 prominent themes, namely longing, awareness, hope, testing concerns, and work from home experiences. And we also observed how these themes progressed or trended through time. So performing temporal or time-based analysis indicates that Filipinos use Twitter as a source or medium for sharing their thoughts, in which it degrades over time as they adjust to the environment. And further works or future work for this study include a large-scale analysis of tweets spanning further than the collected time frame, as well as the use of other algorithms that can withstand noisy text other than latent Dirichlet allocation. So that ends my presentation. If there are any questions, I am willing to answer.
Thank you. Thank you for your presentation. Any questions?
One question, please. Can you tell us more detail? Do your results are used in decision support systems, corporate or government, for decision making? Because results it's very interesting, and for example, government can make decisions on these results.
Yes, that's
the results of this analysis.
That's a good question, because we have another study in which we use the same type of data, only that the tweets that we used are directed to government officials. So we use the same methodology that we used here, and that's what we presented last month in our local government unit. Okay.
Thank you.
Okay, thank you.
Thank you. Thank you, everyone.
Now we will move on to Dr. Milton Saulo Raimondo, will present Forex movement direction predictions with similar wavelet patterns. The floor is yours.
Can you hear me?
Yes, we can.
Can you see my screen?
Yes, we can.
Okay, first of all, good morning and good afternoon for all the others here. It's still 7 in the morning, okay? My name is Milton. I will present the summary of my paper, Forex Movement Direction Prediction for Similar Wavelet Partner. So the agenda for today is gonna be what was my motivation, the wavelet decomposition overview, the new indicator as WVP, similar wavelet partner, proposed by this paper, and the traditional indicators. The data source Forex using by this paper, the methodology applied, and the results and the conclusions. Motivations. So forecasting investment data is difficult due to its diversity, volume, and complexity. This scenario motivates a rapid development of a new perspective in methods of visual analysis, including trend indicators. The Forex market is the world trade for the decentralized currency market. And in terms of market volume, this is the largest market in the world. So the main dealers in these sectors are global banks responsible for setting the relative prices of different currencies. Many economic, political, and even psychological factors affect exchange rates movement, making forecasting this type of series neither an easy or a trivial task. Despite of the good results found in several recent studies, the challenge of finding models with better data forecasting capacity is still open. And the objective is to develop a new trend indicator, SWVP, similar wavelet partner indicator for Forex security. So talking about the wavelet decompositions. Wavelet decompositions are very useful mathematical technique for numerical studies and manipulation of discrete signal. The wavelet expanding the data ranges divided into different elements of scales and frequency, allowing an inspection of each element and its proper scale. The idea of estimation by approximation function was initially with the studies of Joseph Fourier, who detected in 19th century that it was possible to apply cosines and sines to define different functions. The innovation with the wavelet is associated with the fact that the base of Fourier functions are independent of the time, but dependent on frequency. Wavelet are dependent of both domains, in frequency due to expansion and in time due to translation, with an advantage in several cases. So this is only an illustration of the wavelet families. So the first one is R wavelet. The second is the Dalbrich, the third is Coe-Flat, and the last one is Gaussian, and all of them in order 4. This is printed by using MATLAB software, okay? Talking about the SWVP indicator and the other traditional indicators. The SWVP indicator is formulated to forecast trends in financial series, which integrated the wavelet family of functions based on partners with one periodic functions, conceived for translation and expansion of the wavelet mother, highlighting the ripples with the better correlation with the original series, generated point of interest, in this case, buy or sell positions. Wavelet partners are applied to learn the historical time series, trained models, and employed to forecast the next movement trends, which is compared with different indicators. So this flow chart is a step to take to select the wavelet and further trade analysis, okay? Again, the goal is to predict the trend of the next movement in Forex time series. First of all, using the discrete wavelet transform, the original series is sliced n wavelets using one of the wavelet family shown here, okay? Then is verify which wavelet is most correlated with the original series. Then after that, the wavelet select is plotted over the original data series. And finally, the crossing points are calculated. So let me say about the 3 traditional financial indicator markets, okay? The first one is the moving average indicator. The second is crossover indicator. And the third one is the Bollinger Band indicator. There are several, okay? I choose the 3 because they are really popular, okay? The moving average is an inventory indicator helping to steady the price by generating a continuous update average price. A rising moving average indicates that the asset is an upward trend, while a downward moving average indicates that this is a downward trend. Crossover, it's a point on the trading chart where two indicators cross, or whether a line or a technical indicator and the price of the asset cross using the moving average. The third one, okay. Developed by John Bollinger, the Bollinger Band is determined of a set of trend lines plotted by two standard deviation from a single moving average for a given security price. Talking about the data source Forex, okay. The foreign exchange market, or Forex, is the largest world market, and both historical and intraday series is easily retrieved from some open or public knowledge base. The main dealer in this sector is the global banks, responsible for setting a relative price of different currencies. The main Forex centers are London, New York, Tokyo, Hong Kong, and Singapore. These markets trade non-stop 5 days a week and are influenced by many geographic and economic factors. The most traded currency pair on Forex market today is GBP against dollar, American dollar, USD, 12%, 13% US dollar and Japan yens, JPY, and 20% euro against dollar, American dollars. This article selected the Forex time series for the parity between the currency of US dollar, USD, and Brazilian reais, BRL. So this is the methodology, and this work chart has the steps to use SWVB indicator to forecast the trend in financial series. First of all, there are instantiations of open knowledge base. Then the series is plotted by checking its shape and vertical and vertices contained in generated curve, as well as the trends and seasonalities. Then, using discrete wavelet transform, the original series is divided in n wavelet using one of the wavelet family described here. Then it's verify which wavelet is the most correlated with the original series. Finally, the selected wavelet is plotted on the original series, generated the crossing point in between the selected wavelet and the original series, or point of interest for buying or selling positions. Well, this figure shows the original series, the left one, and divided in n wavelet using the wavelet simulate, the right graph, okay? So the original series is the left one, chart with the intraday series. I selected the intraday series for 1 day, okay? For Forex USD BRL asset prices, which 1 minute interval, 571 point of the series is sampled here. So the table at the top summarizes the correlation between the wavelet and the original time series, where the third line is the mean square error and the fourth line is correlation coefficient. And this chart here is the main test to process and execute the test for final analysis, okay? So after the wavelet partners are applied to learn the historical trend models, analyzed against different indicators such as moving average, crossover, and Bollinger Band, is to verify the ability of and efficiency of the SW indicator to predict trends in financial time series, particularly forecast securities. First of all, using the original time series, the moving average and its crossing points is calculated. Thereafter, in the same way, is calculated the crossover and the Bollinger Band indicator. What?
2 minutes left.
Okay, and its crossing point. Finally, following the steps detailed in the methodology, the SW indicator and its crossing point is calculated. Well, this is the result, okay? So this figure displayed the graph is extracted and generated by the indicator moving average, the label A, crossover label B and Bollinger Band letter C, as well as the SWVP indicator marked as D in the graph here, plotted on the original series. Analyzing the point of the graph in the figure, highlighted by these small gray rows, it's possible to recognize that SWVP indicator exceeds the number of correct answers when compared to the moving average, crossover, and Bollinger Band A, B, C, D in the graph. These last three indicators have been shown to be weak and hit some points which can lead false alerts, entry and exit position within realistic buy or sell positions. So the results that I have, okay? This article emphasizes some significant trends indicators used to train the forecasted for financial securities, such as moving average, crossover, and Bollinger Band, and present a new and suitable indicator as the WVP indicator to forecasted trends, particularly for forecasts for Forex security. The SWVP indicator has proven to be capable to predict the trends in Forex assets, which can be also confirmed by the contents of the table shown here, which include the mean square error and the series correlation coefficient generated by using wavelet simlet to calculate the crossover point with the original series. Its operation, like other conventional indicator, are much better and surplus traditional indicator in forecasting trends for Forex time series. Well, there are some additional studies though, okay? One of them going to be the applicability of their others wavelet families. Also, the order of the wavelet employed here. I used the fourth order. Usage as wavelet with less correlation. I use the second correlation, could be the first, could be the third. And the original series and the other security could be also complement the study too. Any questions?
Thank you for the presentation. Are there any questions?
One question, please. What can you tell us about the competitors of your methods? I know that this approach with wavelet function is very famous. What 20 years ago we used neural networks for this prediction on Forex, and now, and I've heard that wavelet methods approach other scientists and specialists I used. What can you tell about your competitors on the real, in the real practice, for example?
Well, let me say, this is one a new trend that I developed, but it's not completed, because if you stay with the trader in a trading room, you're gonna see that the trader use more than 2 or 4 technical analysis to, let me say, have a position or to determine what they're gonna do. And this needs to be also completed, because some points, I also works with the trader to check this new trend analysis. And I realized that this is not only one point that they need to generate. Normally, he's looking like at 3 or 4 points after and before the time right now. And also they need to have some forecasted method to forecast the next point of the security, you know. So this is also could be a complement this work that I developed here, you know.
Thank you. Thank you.
Thank you.
Okay.
Now we will move on to Dr. Ngoyen Hu Owak Day will present the security concerns and countermeasures towards V2V and autonomous cars. The floor is yours. Dr. Kayon. Okay. I think there are no.
Okay.
Okay.
Okay, just a moment. I will share my screen. Okay. Okay, did you see my screen?
Yes, we can.
Okay.
Full screen, please.
Yes. So, good afternoon, ladies and gentlemen. My name is Hùng Đại. I come from Doctoral School on Safety and Security Science, Óbuda University in Hungary. Today, I would like to introduce my research work with my colleague, Professor Ronnie Zondan, with the entitled The Security Concerns and Countermeasures Toward Vehicle-to-Vehicle Communication and Autonomous Car. Our research work based on the Shenzhen 2020 project supported from EU for Hungary. Here is the list of the content of our presentation. So, for example, introduction, cyber attacks in V2V communication, possible threats and attacks, countermeasure and solutions. So, as you know that the traffic accident can cause massive traffic congestion, which can lead to the huge delay in the road, family sorrows, and social burden. The major aim of autonomous car is to improve the road safety and give the possible solution for this problem. Vehicular ad hoc networks, or you can call VANET network, refers to a special mobile network communication for exchanging the data amongst vehicles. And this system enhance the level of the safety of the drivers, reduce the rashes or injuries. There are two types of the VANET, two-type communication in the VANET system. First one, vehicle-to-vehicle communication. The second one, vehicle-to-infrastructure communication. The main purpose of this research is to explore the basic concept, several security concerns, and countermeasures toward V2V communication and autonomous cars. An autonomous car refers to a car that determines the best way to destination and arrive automatically without the driver assistance. According to National Highway Traffic Safety Administration, they clarify the autonomous car into 5 types. First, no automation, then some function with a specific automation, for example, a brake system or the window system, and so on. Then the third one, combined function automation. The fourth is the limited self-driving automation, and the last one, full self-driving automation. As I mentioned before, there are many benefits of V2V communication. However, there are several cyber attacks in V2V communication, such as in controller area network, in car wireless network, electronic control units, and cooperative adaptive rush control vehicle stream. So the CAN system, it means that it can replace the electronic wiring system inside a vehicle. It can help to reduce the cost, the complexity, the weight for the car. However, the attacker can take advantage of the security holes of it by using car shark software. Moreover, TBMS stand for Tire Pressure Monitoring System. It was the first wireless network, and it provides the road safety, enhance the traction, save fuel because of the preventing the tire failure. However, there was an illustration that the attacker can attack the TBMS during a 40-meter distance. Furthermore, attacker can control ECU to execute some modules in the body, engine, electronic brake, and so on. Now, I would like to introduce to you several possible threats and attacks in autonomous vehicles. For example, the carry-in device, malware and software malfunction, malicious hacking, and so on. When the driver or the user used several smart devices such as USB, iPod, smartphone to connect to the vehicle, it is easy to bring the viruses or malware into the system. Besides, there are several failures such as operating system failure, phones sensor, and software errors. So significantly, in 2015, there was an illustration to hack a car based on malicious hacking software and wireless connection. Besides the possible threats, there are several attacks for the autonomous vehicle. For example, DOS, denial of service, or DDoS, distributed denial of service attack. As a good example of a DDoS attack or DOS attack, you can, if you watch the movie with the title Fast and Furious 8, you can see that the attacker can send some commands and control all autonomous car to attack the target. Moreover, in our research, we also figured out the hybrid DOS or DDoS based on the availability, confidentiality, and authentication. So on the figures, you can see that there are several type attacks and with their effect. For example, with the spamming, it can using the a lot of commands to make the bandwidth of the network overflow, or even like GPS spoofing. They can the attacker can get the identity or geographic location of the vehicle on the network to fool them, and so on. Moreover, we also found out that there's some attacks for the camera and LiDAR. As you know, that LiDAR is a sensor that emits the light vibration and calculate its time reflection to detect the objects in the weather condition. However, the attacker can use several attacks, for example, replay jamming, spoofing attack to make noise or fake echoes, and it can lead to make a confusion for the collision avoidance system for the car. So after doing research or on the possible threats or attack, we figured out that in the VANET system, the transferring message do not consist of any sensitive data, but it only requires the authentication without the encryption or no need for confidentiality. Therefore, we propose that the digital signature are the best option because they can use the asymmetric cryptography with the public and private key infrastructure, and it can provide a method to prevent the impersonation attack and so on. Moreover, in the VANET system, it consists some of the communication technology such as Bluetooth, radio, cellular, GPS, Wi-Fi, and so on. And each technology has a different standard, frequency band, data rate, and uses. Hence, when any network is under attack, it will automatically stop this network and shift to another network. Fortunately, that the DSRC dedicated short-range channel has multiple channels. Therefore, it enables the shifting ability for the hop from one frequency channel to another one. A communication device help the vehicle connect to the network with the infrastructure is called onboard unit or OBU, and this part can be integrated with multiple radio transceiver for transferring the message. So it also creates the chance to change many radio signal or channel to keep the network working when it's under attack. Moreover, we also found out that for the camera attack solution, for example, a removable near-infrared cut filter tool. With this tool, it can help to separate the light between the day and the night. This filter can help the camera brings the better image, but this measure is just only effective in the daytime. The second solution is that photochromic lenses. When you use this method, it can change the color to clarify the lights for the camera.
That's left.
Yeah. So in the conclusion, we figured out that for autonomous car can help to reduce the stress, traffic jam, delays, accident, and so on. Also, we figured out several challenges for autonomous vehicle and V2V communication. Also, we also found out the impacts of security threats and possible countermeasure in order to increase the awareness of these security threats to autonomous vehicle. Thank you for your listening. I'm open for your question.
Thank you. Thank you for your presentation. Any questions?
One question.
Yes.
Perhaps I have not heard about real practice application of your system in your country, for example, because as I know, in different countries, Elon Musk, they they're making these things too, and their instruments are working now. What can you tell about the real practical implementation of your?
You mean that for preventing the GPS attack? Actually, for the GPS attack in several countries, especially for developing countries, they use some special technology to encrypt the signal sending from the OBU to the vehicle infrastructure are located on the roadside, and I think that for that attack, it's very hard to sorry for that attack, the another solution is that to use another technology. For example, use the local GPS sorry, not GPS, a local map, and it can encrypt the signal, so it can protect the whole, not just only for the online but offline.
Oh, thank you very much.
Okay.
Okay, thank you. Now we proceed with Dr. Saurabh Shukla, who presents secure data transmission in smart meters using Q-learning and fog computing environment. The floor is yours.
Okay, thank you for inviting me for this presentation, and let me share my screen first. Okay, I hope it is visible to everyone.
Yes, it is.
Okay, thank you. So the title for my today's presentation is a secure data transmission in smart meters using Q-learning in fog computing environment. The contents for the today's presentation are: first, the introduction, a 3-tier fog computing based blockchain architecture, the proposed advanced system model, network model and transaction process, how the inscription and description is going on with the help of proposed smart meter Q-learning inscription algorithm, and at the last, the results should be there. So in the introduction, it's just a very generic difference between a traditional grid and a smart grid. As we know that traditional grid is somehow, it is not somehow, but it is basically a one-way transmission of energy, a one-way flow of energy, whereas smart grid outperforms the traditional grid in many ways. First of all, it is a two-way transmission of both energy and the information. So that is how the smart grid basically a distributed network, which is consists of microgrids, houses, other plants, electric vehicles, power stations. So here everything is connected bidirectionally, and there is a flow of information and energy too. Next, smart grid. Actually, smart grid is basically an example of Internet of Things. Anything which is connected with the internet is called Internet of Things. So smart grid is also connected with an internet. Talking about the cyber physical system, why it is a cyber physical system? Because it consists of a hardware which is integrated with the software part. And whenever a system becomes a cyber physical, it means there is a communication, there is computation, and there is a networking. So this is all is happening in a smart grid network. And as I already mentioned, that it is a two-way communication. And basically, in other words, it is an energy-based internet, whereas there is a flow of information and there is flow of energy also. So as I just mentioned, that smart grid network consists of smart meters, and these smart meters basically consist of microprocessors, and they're also connected with internet, thus measuring how the electricity bills and other the transactions of the users. So basically, it's sends the information to the utility office and the meter management system, and it computes the consumptions also. So, and it can be connected and disconnected remotely as per the requirement of the user also. So as if we know that whenever a system becomes a cyber physical system, there is a possibility for outside attackers or intruders to attack on the authenticity, reliability, integrity, and confidentiality of data. Who is sending the data and who is receiving the data? Is the data is authenticate? How can we identify the users? Is the data is reliable? All these questions comes in our mind. So out of this, one of the attack, which is of the primary concern in the cyber physical system, such as smart grid network, there comes a false data injection, where the attack can be on the smart meter device itself, attack can be on the data, attack on the privacy of the communication, attack on the network itself. Because the smart grid network consists of many networks like household area network, building area network, local area network. So there is a possibility of attack on networks also. So we have the attack in smart meter itself, where anyone can force the demand request, can play with the request amount of energy, and can interrupt the supply and demand process also. So it may leads to misleading the electrical utility, and it may have a misconception in the society that smart meters are not secure enough for the secure data transmission. So we can inject, even not we can, but even the outside attackers can inject the false energy data also. And then there is an injection of false link state data also. So what is a false data injection attack? So basically anything in which we compromise with the readings of the smart meters, and we can we can mislead the sensor readings. All this can result in a different state estimation of the smart grid network, which leads to defined as a false data injection, and it can disrupt the energy distribution of a distributed smart grid network also. So the conventional model or the traditional model of transmission in smart meters is generally consists of data connectors, which are just connecting the data flow of data from household area network, which consists of smart meters, and then it goes to wide area network, that is a meter management system, which are again connected to routers and to the cloud. So there is, as we can see, that there is no proper security or the privacy of the data, which is a major concern. Here we are just proposing a 3-tier fog computing based architecture for smart meters, where the smart meters are transferring the data to the fog servers, which are acting as an intelligent device, which are just classifying the data, which data is a malicious data, which is not a malicious data based on the algorithm used. And they can transfer the data because fog can act at the edge. It acts as the edge of network, so it can transfer the data in a single hop count also. So we have the ledgers and the smart contracts inside the fog. We have the fog server acting as the miners itself, and it keeping the tracks of the blocks also, number of the transactions going on. Although we cannot replace the cloud, so it is the other data can be transferred to the cloud. So the proposed system model for the data transmission in smart meter consists of fog nodes as a middleware layer. Here we can see that there are 3 layers. One is the edge, which is consisted of smart meters, that is acting as a household area network. Then we have a middle area network, a middleware layer, which consists of fog nodes, and these fog nodes are distributed, and they are acting as a miners to identify the false data. These fog nodes are connected to data connectors, which can again transfer the data in a single hop count to the meter data management system. And the data is a private and secure data. The rest of the data can be transferred to the cloud data center itself. So here the timestamp is attached to every blocks, and that each block gets stored in the fog nodes. And here the proposed algorithm is functioning itself, which is classifying the data, and then securing the data using the inscription and description technique used in this algorithm. Moving ahead, how the communication is going on is a very generic diagram. How the communication is going on, there is a control center which is connected to fog nodes, and then there are the routers which is connected to the power plant itself, and this is connected to other building area network, which consists of neighbor area network also, and which is connected to again with the fog nodes, and which is connected to at the last home area network or the household area network, where all the electrical appliances are connected to the routers. So this is how the communication in smart grid system model is functioning with the help of fog nodes. So the network model consists of basically the mutual authentication between the household area network and the service provider. And then there is a key agreement also. And at the registration of the keys at the fog itself, which is controlled by again by the master fog node. And there is a control center, which consists of all the information, how this authentication and verification is going on in this network model. So the transaction process consists of block hash. Transaction process consists of various blocks in which the transaction is occurring from a smart meter to fog devices, and they are signed and verified using the smart meter device with the help of public and private key. Again, the transaction process is going between the individual fog nodes, and the same thing is happening, that the verification of the keys and the signature of all the keys. Here we are here we are using the signature because we want to have selection of public keys from the large pool of public keys so that the authenticity can be achieved. So the inscription and description model consists of here the data packet is encrypted with the help of a symmetric key, and a signature is added by forming a ring, which is already consists of a pool of public keys. Then the ring is again transferred to the fog node for description. Fog node verifies the ring and decrypt the key, and with the help of cyber keys. And at the last, the description process takes place at the individual fog node itself. So the data is encrypted and then decrypted between the transmission from smart meters to fog nodes.
2 minutes left.
Yeah, and why we are using Q-learning? Because Q-learning is basically to predict the transition probabilities and rewards. Here, the Markov decision process is solved using Q-learning because smart grid network works in a stochastic environment where the state of the system changes rapidly and randomly. So to predict the correct probability and rewards, that is the minimum the data error, minimum the packet error or the false data injection, higher the reward will be there. So this is based on this concept. So as it is a generic equation, basically we are just satisfying the Bell-Manford equation and predicting the different transition states depends upon the action taken. That is selection of secured electric data packet. Higher the reward means the minimum will be the raised data injection percentage. This is the algorithm process flowchart. First, the data is classified. Then the fog server virtualization is there. Then the packet allocation is done using the Q-learning approach. A timestamp is attached to the encrypted data packet. Fog node receives the key for verification, which I just mentioned and explained the inscription and description process. Mining, inscription, description occurs at the individual fog nodes. Hash code and data format is checked again with the miner status. Verification of smart meters and fog nodes occurs at the individual fog nodes. Then the data is transferred in the real time using Spark as a real-time analyzer. This is the whole functioning of the algorithm for this smart meter based Q-learning inscription algorithm. Then based on this, we have used iFogSim as a simulator to simulate the fog nodes. And this is basically simulator used for the resource placement, and it is just a part of a cloud sim. And then we have used classified the ESA using principal component LSSs and using 2 PCA SVM classification. And then there's a comparison of packet error in fog and cloud, and then the comparison of how the malicious node percentage versus detection accuracy in fog and cloud. So here the individual fog nodes are deployed in the iFogSim simulator. And the future work, because we are targeting to submit this paper as in a general. So the future work includes the benchmarking with the existing works, cross-validation to tune the model parameters, and to check the algorithm for the reliability and consistency. What will happen if the data size increases? Next, to evaluate the performance parameters also, like positive predictive values, sensitivity, how the results are accurate with the difference in the actual and predicted values. And then the collection of electrical data from the smart meters is also a challenging issue if we want to collect the data in the real time. So this is all from my side. Thank you for listening me, and I'm happy if you have any questions.
Thank you. Thank you for your presentation. Any questions?
One question, as I decided to give one question for everybody.
Yes.
Thank you very much. Very interesting report. I noticed that you want to apply very different methods. And as you know, every method will have its problem. No, for example, you want to use blockchain technology for secure data. It's a very good idea. We know it creates, it helps to create the trust space. It helps to secure data. But did you calculate the volume of data? Because you understand my question. Because the using of blockchain will require to take into consideration the growing volume of data. Did you calculate something, or you make any restriction in your? Thank you.
Thank you.
This volume.
Thank you, Professor. Actually, it's a nice question. What I understand from your question that you want to ask that will the blockchain system or the method you are using will calculate the voluminous data? Okay. As I just mentioned that smart meters are the part of IoT devices, maybe an example of IoT devices, and they are generating a large, a voluminous amount of data. It will be a challenge to handle such a large volume of data. So what we are going to decide in the future because if there is a latency issue with the increase in the size of the data or the volume of data, then the data is not relevant if we require the data in real time. So that's why we have used or we have just explained the concept of fog computing, which will acting as a middleware. We are just targeting the real-time data. All other data will be transferred to the cloud. Only the real-time data will be used as such for the securing and privacy in the blockchain, as if now we are just concerned on the real-time data. So we are just rather all the historical data or the large data is directly transferred to the cloud. What we have decided to reduce the complexity of the system, because when we talk about using fog computing blockchain, it will also increase the overhead related to energy and cost and the complexity also, because we are just have an inclusion of a third layer as such. So maybe it will be a drawback of our system, but we are targeting to reduce the complexity by just transferring the real-time data to the blockchain from the help of fog computing.
Okay, thank you very much.
Thank you.
Understood. Thank you. It's very important. Very interesting system. Smart.
Thank you. Thank you. Thank you all. I sincerely thank our authors for their excellent presentations and contributions in this session, and all our participants for being a part of this international congress. I hope this session was informative and knowledgeable as well. All the presenters would be getting their digital certificates through mail within 2 working days. Further, all the papers have already been forwarded to Springer. The publications will be live within 4 to 6 months. Kindly cooperate with the team of ICICT 2021. I also thank our session chair, Professor Alexander Rykov, for chairing the session. A token of appreciation to the chair on behalf of team ICICT 2021 and Global Knowledge Research Foundation. I kindly ask you to turn on your cameras for a screenshot of this virtual conference. Thank you all. Stay safe and take care. Thank you.
Okay, thank you very much. Thank you all.
Bye.
Very good organization of the conference.
Thank you.
Okay.